Example 3. Find the relative extremum for the function fx equals 4x cubed minus 3x squared. Finding relative extremum involves this following 3 steps. As we are in the first step, we need to find the critical points. We will start doing this from the function fx given in the question. This function needs to be differentiated to find the first derivative. Therefore, f prime of x is equals to 12x squared minus 6x. After this, we need to equate f prime of x equivalent to 0. Therefore, 12x squared minus 6x is equivalent to 0. Coefficients 12 and 6 of this equation can be divided by 6. So the simpler equation will be 2x squared minus x equals 0. This quadratic equation can be solved using factorization method, where we can factorize this into x times 2x minus 1. Solving this, we will have x equals 0 and x equals to 1 over 2. Well, we have seen that the critical numbers obtained are x equals to 0 and x equals to 1 over 2. For these two x values, we need to find the corresponding y so that we can form coordinates. First, when x equals to 0, we can find the corresponding y value by substituting 0 into the function f, in which it will give us value 0. Whereas, when x equals to 1 over 2, f of 1 over 2 is a substitution of into function f, where this will be 4 times 1 over 2 cubed minus 3 times 1 over 2 square, and this will give us value negative 1 over 4. Arranging values of x and y, or else x and f, we can have the coordinates of the critical points. So we have here 0, 0 and a coordinate 1 over 2, negative 1 over 4. So these are the stationary points, or we can call them critical points. Step 2. Now we will perform first derivative test using this table format. Before that, we need some informations such as critical numbers that we obtained earlier, derivative of the function involved, and the number line representing critical numbers in increasing order. To fill in the first derivative table, we will be referring to the number line first. Follow this number line. The first portion of the number line can be written as x less than 0. The middle part of the number line as x greater than 0 less than half. And the third portion is x greater than half. So here in between we have x equals to 0 value and x equals to 1 over 2. Meaning of test value is select a value within the interval. So for x less than 0, we can simply choose negative 0.1. For x greater than 0 less than half, we can choose 0.1, and for interval x greater than half, we can choose 0.6. Next is substituting these test values into the f prime of x function and writing the sign of f prime of x here. We are not interested with the value but just the sign, whether the number is positive or negative. So substitution of negative 0.1, for instance, will give us a positive number. so we write the sign here as positive. When we substitute 0.1 into the derivative function, it will give us a negative number, so the sign is negative, and for 0.6 the sign will be positive. Next is the conclusion. Whenever we see a positive sign of f prime of x, we will say the graph is increasing, negative sign shows the graph is decreasing, and positive sign shows again the graph is increasing. For now, we are able to say that when x equals to 0, we notice that there is an increase in the graph and change to decrease in the graph. So as the graph changing sign from increasing to decreasing, we will say the coordinate involved x is 0 just now as a 0, 0 to be a maximum point. For x equals to half, we are able to see that the sign of the f prime of x is decreasing and change into increasing. So here, when the graph is decreasing followed by increasing, we will be having the coordinate involved x equals to half as a minimum point. So 0.1/2 negative 1/4 is a minimum point. Therefore, the relative extremum now, 0, 0 as maximum point, 1/2 negative 1/4 is as minimum point.